So a salt is formed when you mix an acid and a base together. So for example, if you have HCl and sodium hydroxide, you're going to get table salt, and ACl and water. So the pH of a salt in water is not always neutral. Sometimes it's neutral, sometimes it's not neutral. Well, when would it not be neutral? Well, if a salt contained a conjugate acid of a weak base, then that conjugate acid is going to make it weakly acidic. Salts that contain things like iron 3+, also may be acidic. So when you're drinking water and you measure the pH of that water and it's not neutral, this could be part of the reason that there's some salt in the water, some different ions in the water. So a general rule from the periodic table, group 1 and group 2 metals, so lithium, calcium, sodium, those are all going to be neutral in solution, so you can just remember that. And if a salt contains a conjugate base of a weak acid, then it'll form a basic solution. So it's all about whether the salt derived from a weak acid or a weak base. That's going to give you a clue as whether it's an acid or a basic solution. If it derives, say, from a strong acid mixed with a strong base, then it's going to give you a salt that's neutral. So let's look at some examples. So here we have NH4Cl. So we can break this down and think about where a salt like this would have come from. So it would have come from NH4+, and it would have come from Cl-. So NH4+, let's think about where this came from. What is it? So we want to ask the question, is NH4+ a conjugate acid of a weak base? And what is its conjugate base? Well, its conjugate base is NH3. If you lose a hydrogen ion or proton from NH4+, you get NH3. And so you're really asking, if that's a weak base, then its conjugate is also going to be weak. So you need to know about these guys to see what would happen if you have NH4+ in solution. So how do you know about this? Well, you know about things being weak or strong based on their Kas and their Kbs. So is ammonia a weak base? It has a Kb of 1.8 times 10 to the minus 5. So yeah, that's a small number. So that's a weak base. And so it's actually in this table. So if you have something that's weak over here, then its conjugate is also going to be weak over there. Oh, these aren't totally lined up right. And so the conjugate over here is also going to be weak. And if you weren't really sure, you could always look it up. So here you have ammonium ion, and it has a Ka of 5.6 times 10 to the minus 10. Yeah, that's a very small number. That is a weak acid. So yes, the conjugate is weak, the base is weak, and the conjugate acid of that weak base is also weak. So NH4+ does have acidic properties. It's not a strong acid, it's a weak acid, but it will make things acidic. So this should be acidic. What about Cl-? Do you think it's going to do anything useful for you? Where do you think Cl- came from? From HCl. So we could ask again, is a Cl- a conjugate base of a weak acid? The acid is HCl. Is that a weak acid? No. So we could look it up if you didn't remember it. 10 to the 7th, definitely not weak, very, very, very strong acid. And if something is strong acid, its conjugate is ineffective as a base. So Cl- is ineffective as a base, so it's going to be neutral here. So overall, you have something that's going to be acidic with something that's going to be neutral. So overall, it'll be acidic. So this particular salt and water is going to be acidic because the things that were mixed together to get it, one of them included a weak base. And so that's going to form a weak conjugate acid, so it'll be acidic in solution.